So, hello everybody. Today I'm going to talk about putting your model into production or onto the edge specifically. It's going to be a more top-down approach, not going into that much technical details because every specific case requires a lot of fine tuning. So, who is this guy talking in front of you? I'm Timmermans. I'm a machine learning engineer at Security 360 in Belgium. And if you're on the FiftyOne Slack, you have probably seen me answering questions if you have any problems with FiftyOne. So Security 360, where I'm working, we focus on parameter detection and security. We do this by an edge cloud hybrid architecture. So we do a low or a small AI model inference on the edge, and then a bigger AI in the cloud to do false detection filtering. Currently, we have more than 1,000 cameras operational, and we run this on our custom hardware. The custom hardware is based on a Jetson Nano, and it can run up to 6 streams on 720p concurrently. So what this hardware does is you can connect your existing IP cameras to this device, and then it can do inference on the video streams that come in from that device. So the subject we're all been waiting for is you probably have a very cool AI model trained and created and ready to put into production, or want to deploy it and you don't know where to start. Then this talk will get you started and get the wheels moving. This is applicable to all of the AI models. And this slide is the most important one to keep in mind. Where we can see here is a bit of a hardware checklist of what you should keep in mind when selecting the hardware to deploy your model on. The first one and the biggest one is that your hardware should support all of the operations. This seems pretty easy to do, but for instance, one of the biggest are still a lot of, or one of the biggest alternatives to CUDA currently is MPS for Apple. And in PyTorch, a lot of the operations are still not fully developed. So you will run into a lot of issues with running models natively on Apple Silicon with the MPS backend. We will later see specific software, and you also have to keep in mind that your hardware should be able to run that software. You should look at what is your data that will be coming in, and that your hardware will be able to use all of the bandwidth available, or have enough bandwidth to do inference on all of the data that's coming in. And then lastly, your hardware should have enough flops to do all of the inference on your AI at a smooth rate. So a couple of these flops counters for your AI model can be from FV Core or from MMCV. They both have flops counters. You can calculate them yourself. And you can also, some other AI models like YOLO show you the flops of your model when you have trained it. First, to select your hardware, there's a lot of choice and a lot of different type of hardware. You have very general hardware like the CPU in a phone or desktop, and you would think you need a GPU for AI inference, but with the latest software developments, that doesn't have to be the case anymore. You do have the default GPUs that you hear about every single day, is the big slotted GPUs you can put in servers, but this is not very feasible to put on the edge, and unless you have very big edge or very big data streams, for instance, where we would see the ARM bench being deployed. This could be one of the use cases, but mostly when you want to deploy it on the edge or somewhere small, you want a small AI accelerator like a Google Coral, the Halo accelerator, or NVIDIA's Jetson lineup. Now, we can just run our models with PyTorch, TensorFlow, or if you would train your model with JAX and just run it straight away. That's totally possible, but you will leave a lot of performance off the table. And the software like Onyx Runtime, in the future modular inference engine, NVIDIA Triton, and then you have even more specific ones like NVIDIA's TensorRT, Apple's Core ML, or Intel's OpenVINO, can accelerate your AI inference quite well. But then it's also a big question about mixing and matching the software with your hardware. Like I said in the beginning with the checklist, your hardware needs to support the software. For instance, OpenVINO only works on Intel processors. But as a use case or as an example, we will go with our Security 360 personal example, where we use the Jetson Nano, and then some software already falls short, like OpenVINO, and we are left with the choice of TensorRT, NVIDIA's Triton inference server, doing it in Onyx, or in the future modular's inference engine. And then to give an example, we will just take the bare TensorFlow model and the highly optimized TensorRT model to see the difference in edge performance. On our personal AI model, this is where our model doesn't even reach the 4 FPS into production, where our PyTorch is lacking quite a lot. Everything is done unoptimized. While when we look at the TensorRT model, we have almost a quadrupling in performance, which is, when we are talking about these numbers, workable to not usable at all. To give an example about how do we do this, what makes it possible that suddenly changing from the PyTorch to TensorRT, this is done by some very interesting procedures. The first one, maybe the most known, is pruning, whereby we take out some of the neural network nodes that are not very used or not used at all. So this can be done after the fact as well, whereby we run the model and see where the nodes don't make a lot of sense. Then another cool thing is fusion, where we would fuse the kernels that the GPU would calculate. Like I said before, this is also a very critical part about making sure that your hardware supports the operations. Because as we can see here, this is just the example NVIDIA also gives on the Pascal's VOC model, whereby we can see here that the operations can be fused into one single kernel, and then even further concatenate all of the operations into a single operation to make your flops go, or make your model reduce in flops and make your model do, get higher inference operations. Then another one that's been very interesting, especially in the big large language models, is quantization, whereby we first take our float 32 numbers that normally are used to train our models, and then we basically spread them out in the range. For instance, int 8 is the most used in computer vision, where you spread this out in the range of negative to 128 to 127, whereby here we can squish down a lot of data into a much smaller size. We do have to keep in mind that this is model specific and hardware specific, because as we can see here, to create the weights on this TensorRT model, the model has to be created on the device itself. It can't be that you would create a model on your desktop computer to put into a Jetson, or even if you would create a TensorRT model with one specific GPU, an NVIDIA GPU will not work or will work poorly on another model of NVIDIA GPUs. So this is a big, or one of the downsides about highly optimizing your AI models. You can get a lot of inference, but it takes a lot more effort and time to get these models into production. One method of gathering around this step is dynamically building your model when you would deploy it to a customer. This will work, but you do have to keep in mind that it will make your first run pretty slow, because your model has to be built from scratch in the beginning. But then we have our model. How do we run it? For TensorRT, there are a couple of ways to do it. We can use the native Python bindings or C, C++ SDKs to create our fully end-to-end model ourselves. But NVIDIA also has some niceties created for us. That was the Triton inference engine that I said earlier. But they also have a special application called DeepStream. I will talk a little bit more after. And then also the Onyx runtime. This is the most versatile while still having the ability to run these highly optimized models. But once you created this pipeline, it also makes it possible to change out your TensorRT model for something else. For instance, when you would run different hardware or your model changes, you can switch out the TensorRT model for something else with the Onyx runtime. For our example, for what we use at Security 360, we use DeepStream. Now, the nicety about DeepStream is that it's built upon GStreamer, and NVIDIA has made some plugins for it. These plugins are highly optimized to run on NVIDIA hardware, like, for instance, the tracker of your model. So the boxes that are generated can track the model as well, and also draw the boxes itself. When we are talking about edge devices, it's and just thinking about drawing boxes on the screen, that you would think about that doesn't take a lot of processing power, but every watt in the edge matters, especially for those small cases like we see here, or small hardware. And then lastly, how do we deploy this model then eventually, or how do we deploy our full application? We can do that in a couple of ways. Our way is to do it with Azure IoT Hub, so we can version our models and version our applications and push our application remotely onto somebody else or on our client's hardware without them having to worry about keeping up with updates. Another way to go about this is building your own OS with something like Yocto, or you can have something like in the Docker Hub, where your clients could just download your program and set it up themselves. And that was my presentation. Thank you. And are there any questions? Do you deploy the model in HPC AI supercomputers? I'm assuming this is concerning the hybrid approach that we're talking about, that we're running AI in the cloud, but no, we don't use that supercomputer specifically.